All right, class, welcome to this video on 4.4 practice. These are the questions from Canvas. So let's go ahead and get started, just in case you're having trouble and you need a little help. So the first question here, for each triangle, determine if they are congruent. So, and then by what theorem? So we have here, we got an angle corresponding to the angle on the correct side. We got another angle corresponding to another angle here, but then we also have a side in between those two angles, and this is by reflexive property. Remember that if they share, then that side is congruent to itself, and that counts. And so we have a side. So this is going to be angle, side, angle. All right, and the next problem we have an angle corresponding to an angle on the other side for the other triangle. We got another angle here corresponding to this angle, but we also have a side, an included side, or the side that is between them, by reflexive property. They have to be the same, and so this is going to be ASA for both. So they are congruent by ASA. And we have a side here corresponding to this side. We have an angle corresponding to the correct spot on the other side as well. And we don't know anything else, but right now, they don't say anything else, but we do know another angle, because we know that these two angles are vertical angles. So by the vertical angle theorem, they have to be congruent. And so these guys are actually congruent. All right, and so because they're congruent, we have another angle. So this is going to be angle, angle, side. All right, this one we have angle corresponding to this angle, angle corresponding to this angle, and angle corresponding to this angle. And so this is angle, 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 but we know that we cannot determine congruence. These are not congruent based off of this. And you can't use angle, angle, angle. So can't be determined based off of this information. All right, so here we have an angle corresponding to an angle here. We have a side corresponding to a side here. And they're in their correct spots because they're opposite of each other on both triangles, so that makes sense. And now technically we have another angle, right? Because we know that these are vertical angles, and so they have to be congruent. And so now we have angle, angle, side, angle, angle, side. Right? We have side corresponding to a side. And we have a side corresponding to a side here. And there's no other pieces of information, right? So we cannot determine congruence here. All right, let's look at the next question. What additional information is needed to know the triangles are congruent with the given method? Type the letter for your answer into the box. Okay, so first triangle, we want angle, side, angle. And so we have an angle here. We have a side, because this is by reflexive property, right? And okay, well, we have an angle and a side. Looks like we're missing an angle, right? Because we want angle, side, angle. So what angle are we missing? We're missing this angle. We need to know that that angle is congruent to this angle. And then that would be angle, side, angle. So angle, side, angle. All right, and so we need to know that angle QCD is congruent to DAE. Or here, let me go ahead and do it on here. Yeah, so we need to know, let me erase the blue here. So yeah, so we need to know QCD, which is here, is congruent to DCE. I said the wrong letter, but it's DCE. And so that's this one here, DCE or ECD. It's the same angle. So the answer is B. And then triangle 2, we want angle, side, angle. All right, so we got an angle corresponding to an angle here. We got another pair of corresponding angles, but since we're doing ASA, we need to know the side in between them. So we need to know that this side is congruent, and that will give us ASA. Okay, so we need to know that KL is congruent to UT. Okay, so triangle 3, angle, angle, side. So we got an angle, angle, and so we're gonna need a side. Angle, angle, and side, or angle, angle, side. Okay. On the other triangle, angle, let's see here. Angle, angle, 1, 2, yeah, angle, angle, side, or angle, angle, side. Okay, so either one of those is correct. So we can either know the blue pieces of information, or we can know the black pieces of information, the black sides. So those black sides correspond to each other, and these blue sides correspond to each other. So we have either we need ZY is congruent to NM, so either C, or we need to know that XZ is congruent to NL or LN. So either one of those would be correct. So you can type in either one of those as your answer. All right, so triangle 4, we have angle, angle, side. So we have an angle here. We have a side because by reflexive property they share, they're congruent. It's a congruent to itself. And so I need AAS here. And so the only way to do AAS is it would have to be here, right? Because then that would give me the angle, angle, side in that order. If I were to do it here, then that would be angle, side, angle, and that's not what I want. Okay, so therefore it would have to be there, and then in here it would have to be here so that it's angle, angle, side as well. So we need to know that angle T is congruent to angle E. In other words, we need to know that DTC is congruent to CED. CED is the same thing as DEC, and then CTD, same thing as DTC. So its answer is A. All right, question 3. We have, we're given a proof. So we're given that angle G is congruent to, and let's do this in another color here. So we got this angle is congruent to angle I. We have that FH bisects GFI. So this right here is my bisector. It's bisecting an angle. It's bisecting GFI. So it's bisecting this angle right here, which means it's cutting it in half. So it's saying that this angle is congruent to this angle on this other side. So we know that piece of information as well. So those two angles are congruent. Okay, and so that's the information that they give us. So let's go ahead and fill in the proof here. So this is given, right? Because that's the reason for that. And angle, like we said earlier, this red angle, the two, let's go ahead and color code it. So it's different. So these two are congruent because it's a bisector. Okay, so that's the definition of a bisector. This is an angle bisector because it cuts it in half. Remember, bisects means cut in two. So by the definition of angle bisector, those two are congruent. Now, by the reflexive property, we know that this side that they share has to be congruent to itself. Okay, so that means that FH has to be congruent to FH, has to be congruent to itself. And then, so now we know that those are the same. And so now we got a side, an angle, and an angle. And so this is angle, angle, side. Same here, angle, angle, side. And so now these two triangles are congruent. Remember, when you prove something, the proof goes at the very last statement. So this has to be whatever you're trying to prove. And so those two triangles are congruent by AAS, as we wrote here. And the proof is done. Question 4. In the figure shown, which theorem can be used to show that triangle ABC is congruent to triangle DEF? So we have a, oops, I said side. This should be an angle. We have an angle, angle, and a side, corresponding to an angle, angle, and a side. So we can clearly show that these are congruent using the AAS triangle congruence theorem. Question 5, which theorem is not a valid theorem to show that two triangles are congruent in general? Well, remember, we discussed 4 up to this point, right? We discussed ASA, we discussed SSS, we did SAS, and recently we did ASA and AAS, right? We didn't discuss anything else. And that's because the other theorems, the other congruence criteria, these are the only congruence criteria that you can use to show that two triangles are congruent in general, okay? Meaning that you can use them for specific cases, but any other combination you cannot really use in general for like all triangles. So, and, you know, it's not going to be a unique triangle all the time. And so therefore, the only one that's not in this list is SSA, okay? So that's the answer here. You can't use that in general to show that there's a unique triangle for any, every given scenario. Okay, so question 6. Select all the pairs of triangles that are congruent by ASA. So we have angle, side, angle, angle, side, angle. That is correct. We have side, angle, angle, or angle, angle, side. That's what we call it, angle, angle, side, which is not what we want. We have angle, angle, side, angle, angle, side, so no. Angle, side, angle, angle, side, angle, that's correct. And then angle, side, angle, angle, side, angle, that's correct. All right, guys, that is it for the problem set. I hope you took something from this video. And as usual, I'll see you in the next one.